Yes, a very good morning to all of you. I hope I am audible and visible there. Am I audible clearly and visible? Kindly respond on the chat box so that I can come to know that there are a few people over here and they're able to listen to me and see me. Okay. Mani is there. Sashi, very good morning. Johnny, Lekha, Srimai. Then who is there? Saleha. Okay. All of you are able to listen to me, right? There is no problem, audio and visual wise, from your side. Yes, a very good morning to everyone joining the session. Yes, Prabhavati, very good morning. People have kept the name Tolvi, na? Quite a huge fan of organic chemistry, it seems. Toluene, benzene, I think, I don't know whose name I read before. I'm not able to recall, but it was somewhere, kind of some name of compound there. Okay. So I hope a majority of the people who had to join the session, they're already present here, right? Do you recall what was the last thing which I taught you in the last class? Or else what was the topic which we have started with in the last class? What was the topic which we were learning? Yes, a very good morning to everyone, whoever is joining, right? Tell me the name of the topic. Those people, I think few people I am able to remember. Rani was there and I think few more. Srimai was there. Yeah. Okay. So I think we were learning about basics of inorganic nomenclature. And as usual, let me just, kind of just ask you a few of the questions, right? Which is normal trend which is there in my class. So first, it will make me clear, like it will clarify the things whether you have kind of revised the things or not. Okay. Now whatever is the name of cation or anion I'm taking, try to write down the formula there. After that, we'll proceed further. Okay. This is just a warm-up exercise kind of thing. Now, if at all I say that I have got kind of strontium ion, what is the formula of that? Strontium ion. Very good, Kavita. First one to kind of send the message there. Sr2 plus. Very good. If at all I ask about aluminium ion, yes, majority of you have written it correctly. Sharat, I think by mistake it has been typed. Aluminium, Al3 plus. Good. If at all I ask you about oxide, what is the formula of oxide? Formula of oxide. Correct. If at all I ask about nitride, what is the formula? In the formula, there is only one nitrogen or three nitrogens? Correct. If at all I ask you about cesium ion, what is the formula? Cesium ion. Correct. Madhu has answered promptly there. Cesium ion is Cs plus. Okay. Now, if I ask about cyanamide, Cinamide. No, Nikshita beta, that is not Cn minus. I think Srimai has written it correctly, even Johnny too, right? Lekha also, Sarat also. This is Cn22 minus, and those who are saying Cn minus, actually that is cyanide. Okay. Quickly answer for peroxide. Peroxide. Peroxide quickly. One or two I'll ask. After that we'll come to the normal this one. Correct. Peroxide is O2 2 minus. What about superoxide? Superoxide. Superoxide is O2 minus. Okay. So it's good to see that people have revised the things. So we have completed for naming of the cations. We have started off with the naming of anion. And in that anion also I told you, generally we derive anion from hydroacid and the other one was oxyacid. So first of all, we have seen anions from non-oxyacid, right? Now let us go for the next one here. Whatever is the sequence which I have given you, maintain that. This is the second part in the naming of anion itself. Whatever is the way we have numbered 1 or 2, maybe Roman letter, you can continue with that, right? So next is anions derived from oxyacid. Anions derived from oxyacid, or else oxoacid also we can say. Okay. Now, the thing is, we are going to, kind of go for certain elements and their oxyacid or the anions derived from their oxyacid, and I'm going to give you the most common ones only because they are only going to be much more useful throughout. If there is anything new ion which you come across or new oxo anion which you come across, need not worry about it. As the syllabus will progress, it will get covered in that. But at present, just to build a strong foundation, I am going to give you only few of the very common ones. Okay. Now, the first one is when I say what is oxyacid. So I gave you definition. Do you recall what was oxyacid, by the way? What was oxyacid or oxoacid? In oxyacid, you will be having hydrogen, oxygen, and as well as at least one hydrogen will be connected to oxygen, right? So I'm going to write down that only. So the acid which contains hydrogen, oxygen, and other element. Now, in this I am writing one more point. At least one hydrogen must be connected to oxygen. That means I am saying OH like this, right? For example, if I write down simplest one, this is an oxyacid of carbon. You're able to see oxygen, hydrogen there, and you are having oxygen-hydrogen bond, right? Now, you must know why we are saying one OH minimum should be there. Do we have the idea of electronegativity, right? So simply, the thing is, when I say electronegativity, simply you understand that it is a tendency to attract the shared pair of electrons towards itself. That means, normally we might think that suppose there are two atoms here, which have brought their one electron to make the bond, we might think that this is equally shared, and in this case it is like equally shared because both of them are same and their electronegativity will be same. But if at all I talk about kind of two different atoms, so definitely their electronegativity is going to be different here, right? And let me say, I am assuming that electronegativity of B is greater than A. What is the meaning of electronegativity of B is greater than A? That is, B has got more tendency to to attract this shared pair of electrons towards itself, right? So in that case, partial negative here, partial positive here. And once this bond becomes more polar, so in aqueous solution, it will be easier to release B as B minus and A as A plus, right? So going on that line, we know that this is OH bond here. This one will be delta negative. This one will be delta positive. Now the thing is, in aqueous solution, it is easier for this bond to get broken, and I'll be calling this hydrogen as replaceable hydrogen. Replaceable hydrogen, right? Why? Because if at all I am reacting, suppose I am saying H2CO3 is there, you are reacting it with NaOH. Aqueous solution we have taken, you simply mixed it. Acid-base reaction will take place, and let us say I am saying Na2CO3 plus water has formed there, right? So what has actually happened? H plus has been replaced by Na plus, and that's how you are getting, kind of Na2CO3. In fact, both the H plus I have replaced. So that is the meaning of replaceable hydrogen. That hydrogen which can be lost as H plus in the aqueous solution. Getting it? Are you able to understand whatever I have written on the board? Because this term I am going to, kind of use it quite often now in this lecture. I hope it is clear. Shall we proceed further? Okay. Now in this, let us go for oxy acid of carbon and its anion. That means we are going to see for certain elements what are the oxy acid possible and what are their possible anions. Who is this? Sridhar, did you join this session right now? Kya? Sridhar, है ना? Kindly answer. Did you join now only? Or where exactly is your doubt? Tell me. Be more specific for doubt, beta. If at all you have not joined now, it's okay. You tell me where specifically is your doubt, है ना? So that I can rectify that. Which example? I've just given one example. Here the thing is simply you should understand that I am saying replaceable hydrogen. What is the meaning of that? Replaceable hydrogen means in that hydrogen can be replaced by any other atom. So the thing is when I go for aqueous solution of it, this bond being polar, so hydrogen could be lost as H plus from there, and in place of that H plus who is coming? Na plus. So that's what I am saying, that it is replaceable hydrogen. Getting it? Now, when it comes to oxy acid of carbon, there is only one oxy acid existing here. We call this as carbonic acid. Now, if I see the structure of this, we know that this is the structure because previously I have joined it. Now, somewhere when I'll be explaining about the oxy acid, right? So the thing is, I'll be drawing certain structures. You need not, get terrified with that, okay? The thing is how to draw those structures. You'll be taught in detail. Need not worry. At present, just for explaining, I might be drawing structures somewhere, okay? Now the thing is, we know that how many H plus ion can be donated from here, from carbonic acid? How many H plus ion? How many H plus ion can be donated, or how many hydrogen are replaceable? Good, Sridhar, right? So the thing is, can I write down this is 2H plus donor. Now, if at all, it is giving you both the H plus, right? And one more thing I would like to clarify here. If at all for a particular element, there is only one oxy acid existing, there is no other possibility, right? There is no other oxy acid existing, then always its oxy acid will be ending with ic. Like for carbon, you just have carbonic acid. You do not have anything like, carbonous acid or something like that. There is only one oxy acid. Now suppose both these H plus are gone. So will I be getting CO3 2 minus here, right? Now one important note which I am writing here itself, wherever you people are having space, you can go for it. So the thing is, if at all I am having ic acid, the anion derived from this should be ending with the name 8, right? If you people wish, you can write down below this, whatever is the structure we are drawing, below that you can put the note here. Now the thing is, if at all I am having us acid, this oxy acid is us acid. In that case, you are going to write down the name of anion will end with 8 and ith. Ic acid, then the name of the anion should end with 8. Us acid, then the name of the anion should end with ite, ite. I hope this is clear. This has to be followed, right? So the thing is, I can write down this as carbonate. Able to understand? Right? Now, if there is only one H plus lost, right? So in that case, the formula will become HCO3 minus, right? Now, the thing is, I'll be writing the name as hydrogen carbonate, or else, this one is hydrogen carbonate, or else I can also call this as bicarbonate. Now, this hydrogen, what is this hydrogen telling you? This hydrogen is telling you how many replaceable hydrogen is still present in that given ion, right? How many are there originally in H2CO3? 2, right? Once you have lost one H plus, this hydrogen which is there, can it be replaced or not? It can be replaced because it is connected with oxygen. So it is replaceable. So what is this hydrogen representing? This hydrogen is representing number of replaceable hydrogen present. Getting it? Everyone here? Able to get it what I have written? Yes, shall we proceed further? So for oxy acid of carbon, there is only these two cases which you must remember. Okay. Then next is oxy acid of silicon and its anion. So for silicon, you are having its oxy acid as H4SiO4. This we call it as silicic acid. And the formula is, or is the structure of this is like this here, OH, OH, OH over here, right? Now the thing is, if at all I remove all the H plus, how many replaceable are there? 4. If I remove all of them, I'll be getting SiO4, 4 minus, right? So this is actually oxo anion of it. So I'll be writing this as either silicate, or else sometimes you may find out this as orthosilicate. Orthosilicic acid, okay? Based on that, we are retaining it. Is this clear? Please write it down, then we'll proceed further. Sohan, what is your doubt, beta? Hydrogen is number of replaceable hydrogen which is still existing in that ion. Getting it? You'll understand more clearly when we go for phosphorus. Okay? Hopefully people have written that. Shall we proceed further now? Now, let us go for the next one, which is oxy acid of nitrogen and its anion. Now, in case of nitrogen, I have written a formula. What is the name of this acid? Everyone knows it, knows about it. This is a very common one. What is the name of this acid? Nitric acid. Good. So the thing is, this is nitric acid. And the thing is, if at all I draw the structure, it will be somewhat like this here. Time and again I'm saying, please do not bother much about the structure. This is only for your better understanding. You will be able to draw the structure once chemical bonding is taught to you and P-block is taught to you, right? Now, how many hydrogens are replaceable? As such, there is only one hydrogen and that too it is connected to oxygen. So if it loses this H plus, it will be making NO3 minus. Now tell me, this is nitric acid. So what will be the name of the ion there? Quickly write down. What will be the name of? You are having ic acid. What will be the name there? No, Shridya, I'm not asking about another oxy acid of it, beta. I'm asking about the name of the anion. Hai na? Harsha, you are writing the shortcut there. Hai na? Madam, whatever is the name, it should end with 8. The thing is, it will become nitrate. Okay. Let us go further. If at all I am having HNO2, somebody has already pointed out that this is nitrous acid. And when we look for its structure, this is your nitrous acid. Okay. Now the thing is, it will lose the H plus, which is only connected, like hydrogen is connected with only one oxygen. It will become NO2 minus, right? And this NO2 minus is known as what? Us acid. So the name should be ending with, what should be the name? I think people have already written, that is nitrite, correct. So the name will be here nitrite. Got it? Finished? Then we'll proceed to the next one. Fifth one, oxy acid of sulfur and its anion. Now see, for sulfur, if at all you recall a little bit in your P block, there are many oxy acid, but we are restricting only to kind of the most common ones here, so that the common ones or the name which are more encountered in your common compounds will be able to answer. And as and when those other oxy acid will be taught to you, these basics will help you out in kind of recalling their name. Okay. Now, in this you are having actually two oxy acid at present, which we are considering. So you are having here this as sulfuric acid. Okay. Now, when you go for sulfuric acid, if I draw the structure, it somewhat looks like this, right? Tell me here how many replaceable or how many H plus donor it is. Sulfuric acid. 2, right? So the thing is, I can write down that it is 2H plus donor, right? Now suppose I am saying that first of all it has lost both the H plus. So in that case the formula will become SO4 2 minus. Tell me the name of this ion which I have just written. What is the name of this ion? Sulfate. Very good. So the name here is sulfate. Okay, good. Now suppose I am saying that only one H plus has been lost here or replaced here. So it has become HSO4 minus, right? Sohan will answer this particular question. You tell me what should be the name of it in terms of hydrogen. Sohan was there who had little bit of doubt. So I want him only to answer so that if he is making mistake, he'll be able to kind of understand it better. Sulfite, those who are answering, that's wrong, beta. Is it us acid, Shridya and Avinash and even Shrimai? Is it ic acid or us acid? Wonderful, Sohan, right? It is hydrogen sulfate. Few people are answering sulfite. On what basis? What did I tell you? If you are having us acid, then its anion will be ending with ite, I-T-E. Here we are talking about 8. There is lots of difference when I say 8 and ite. Getting it? So thing is here, this one becomes hydrogen sulfate, and I can also call this as bisulfate. Right? And This hydrogen is telling you that there is still one replaceable hydrogen. Suppose this has gone, still there is one more hydrogen which is attached to oxygen, which is replaceable. That's why hydrogen sulfate. Getting it? And we can also call this as bisulfate, the way we have called a bicarbonate. Got it? Chalo, I'll go for the another oxy acid here of sulfur, which is H2SO3. Now the thing is, there is one oxygen less. Sulfuric is H2SO4. There is one oxygen lesser than the ic acid. So it will become us acid. So it will be called as sulfurous acid. So I'll be writing this as sulfurous acid. Now, if at all I go for its structure, it will be S double bond O here. You are having OH, or in fact, let me kind of draw this properly. OH, and a lone pair, right? Whatever are the number of hydrogens, first try to link them to the oxygen. Need not worry about all those rules, you'll be able to understand. So this is H2SO3. How many H plus donor it is? How many H plus it can donate? Quickly write on that chat box. It can donate 2. So I'll be writing this as 2H plus donor. Now the thing is, if at all it is giving away both the H plus, we'll be getting the ion as SO3 2 minus. Now tell me what will be the name of this ion? Us acid. So it should end with what? Ite. Very good, Avinash, right? So the thing is, you are going to write down this as sulfite. Got it? Yes, Akash has also answered. Mani also. Sashi, toluene, na? Srimai, Sohan, Chandraya, Ishwar, right? Now the thing is, if at all I am saying one H plus is lost here, so I'll be writing this as HSO3 minus. Tell me what will be the name here? Tell me the name here. Sulfate you cannot use. Madhu, you cannot use sulfate, beta. Akash has written hydrogen sulfide. That's absolutely fine. Correct. So the thing is, I'll be writing this as hydrogen sulfide, right? Or else I can write down this as bisulfite. Able to get this, everyone? Shall we proceed to the next one? And we have numbered this, I think it is in that sequence 5, if I'm not wrong. Yeah. Now let us go for the 6th one, which is oxy acid of phosphorus, and it's anion. Now when we go for oxy acid of phosphorus, one thing is very sure that in whatever oxy acid you take of phosphorus, there is one thing which is very common, which is nothing but this P double bond O. Whether I write down something like this here, I'm not writing other, kind of only few I'm writing, but you'll see that what is a common thing which you are able to observe. In all of them, if I ask you, I've written few of the oxy acid here. If I ask you what is common in them, O and H is present definitely, and at least one hydrogen is connected to oxygen. Other thing is, every time you are having P double bond O, that is must and should for oxy acid of phosphorus. Okay. So the thing is, I'll be writing here, in oxy acid of phosphorus, P double bond O must be present. P double bond O must be present, right? So just for kind of showing you what are the possible 2 to 3 oxy acid here, I have written that, right? Now let us go one by one here. Suppose if I am writing here H3PO4, right? And I am calling this as phosphoric acid. And as such, I have already drawn the structure of it, but still I'll, kind of write it. Now in this case, you tell me how many H plus ion can be donated here. How many H plus ion? 3. Because 3 are actually attached to the oxygen. So I'll be writing this as 3H plus donor, right? Now let us say that I am thinking that all the H plus which is there, it has been donated. Okay. So in that case, the ion resulting here will be PO4 3 minus, right? It is ic acid. Tell me the name of this PO4 3 minus. Phosphate. Wonderful, right? Majority of you have answered. In fact, all of you have answered correctly. This is phosphate ion. Okay. Now, let us say I am writing it again here. Suppose it is losing only one H plus. We are just going with, this is a weak acid, it will be releasing its H plus in stepwise manner, right? Now let us say H3PO4 is there. I am saying that only one H plus, one hydrogen has been replaced. So the formula will become what? H2PO4 minus. Can you tell me the name of this ion over here? Can you tell me the name of the ion over here? No. Money, from where you are bringing hypo beta? No. Dihydrogen phosphate. Absolutely correct. Srimai and Sohan. We write down di. Now the thing is, see, always when I've removed one H plus from here, look for, if you're not able to see this, right? Are you still having these two hydrogen which are left out? Are they still in the category of replaceable or not? If they are in the category of replaceable, you should write down how many hydrogen ions are still replaceable there. So I'm going to write down this as dihydrogen phosphate. You will not change it to phosphite or something because originally your acid is phosphoric acid. Getting it? Hopefully it is clear to everyone. There is no confusion. Bi or di, anything you can write down, but more specifically you will come across di. Now suppose one more H plus is lost. Will I be writing this as HPO4 2 minus? Now what should be the name? Yes, Ram Babu has written it correctly. Yes. So the thing is, you need to focus on this hydrogen. If at all these two are gone, is this hydrogen still connected to oxygen or not? It is connected there. That means what? It is replaceable hydrogen which we are talking about. So here it will become hydrogen phosphate. Right? Or else sometimes it can also be called as biphosphate, going on the similar line for bicarbonate, bisulfate, like that. Okay. And sometimes you may come across in some text, they might have given you monohydrogen phosphate. Monohydrogen, but the thing is, okay, more commonly we can use hydrogen, but if they are using mono, then also there is no problem, right? Now, if I lose one more H plus which is there, which is replaceable, I'll be getting PO4 3 minus, which is actually phosphate. Done? Everybody understood also? Then we'll move on to its next oxy acid of phosphorus. See, again I am saying for phosphorus and sulfur, I am telling you just the limited number which is more common, more often you are going to, kind of come across. Chalo. Now, second one is H3PO3. We call this as phosphorus acid. Why phosphorus acid? Because in comparison to the ic acid, there is one oxygen less. In phosphoric acid, you had H3PO4. In phosphorus acid, you are having one oxygen less, which is H3PO3. Now, the thing is, if at all I draw the structure of it, it comes out to be P double bond O, OH, OH and H. Now tell me how many H plus donor it is. How many H plus donor is it? Is it 3H plus donor or only 2H plus donor? Only 2. Only those hydrogens which are connected to oxygen, these 2, they can only be replaced or given away as H plus. Not just because a particular acid is having all 3, you will be able to replace all 3 of them. Getting it? So those who are answering 3, mind well what I am talking about. Okay. Now, if suppose it has lost both the H plus ion, which could be replaced, it will be left out with HPO3 2 minus. That will be the formula remaining. If at all I remove 2H plus from here, you will be having this as HPO3 2 minus. Can you tell me what will be the name of this ion here? What will be the name of this anion? See, people are falling into the trap. Why hydrogen? Chalo. Just because hydrogen is present, huh? Is this hydrogen replaceable? Those who are writing very nicely, Varshin is there, Akash is there, Ram Babu is there, even Avinash is there, Madhu is there. Why you are writing hydrogen? Is this hydrogen replaceable? Is this hydrogen replaceable? Yes and no can be the answer. Is it replaceable? No. If it is not replaceable, then we do not worry about it. Okay. So the thing is, it becomes here phosphite ion. You are going to write about only those many hydrogens which are replaceable. It could only replace, from here only 2 could be replaced, and those 2 are already you have removed, already you have replaced. Are we getting it? So those who have written hydrogen phosphite, I hope I made my point very clear. Got it? Is it clear now? Those who have written by mistake, the very first time when I asked the name, those who have written hydrogen phosphite, I hope I made my point very, very clear. We are writing about only those hydrogens which are still replaceable. If it is not, then we need not bother. Okay? Now, next thing is there is one more name to this. This is phosphonic acid. There is one more name, like one more commonly known name of this is phosphorus, we are aware of, but there is one more name to it, which is phosphonic acid, right? So you can remember phosphorus, so similar sounding is phosphonic, right? Going on that line, for the same one, can you tell me what will be the name here? If at all it is sulfuric acid, what you are doing? You are removing ic and you are bringing 8. That's what sulfate. Sulfuric acids. Yes, Avinash, very good. Phosphonate. And Akash, you have eaten nate, N there. The thing is, it will become phosphonate. Same ion, another name. This is like less commonly asked, but you should be aware about because phosphonic acid is the other name of this phosphorus acid. Getting it? So you are simply removing ic, bringing 8 over there. Are we clear? Shall we proceed to the further part of this particular acid? It's good, majority of you could answer correctly. Now, suppose I am saying here you are having H3PO3. This is phosphorus acid. And 2H plus it can lose, but I am saying that in one step we are making, we are removing 1H plus, right? So if at all I remove 1H plus, it becomes H2PO3 minus. Tell me what should be the name of this ion? What should be the name of this ion? Should I write down dihydrogen or only hydrogen? And should I write down phosphate or phosphite? Madhu, Srimai, and I think Sohan. Avinash also. Correct. So the thing is, I'll be writing this as hydrogen phosphide. Reason being, you are able to see two hydrogen, right? When suppose these two hydrogen are there, this hydrogen is gone. Out of the two visible hydrogens, which is replaceable? Only one. That's the reason you are writing only one there. That is hydrogen phosphide. Okay. Then, if I remove one more H plus from here, it becomes HPO3 2 minus, and this we have already seen the name, which is phosphite ion. I hope it is clear. Clear? Shall we proceed to the next one then? Third one, and this is hypophosphorus acid. When I talk about hypophosphorus acid, formula is H3PO2. Now, what is the formula of phosphorus acid? It is H3PO3, right? In comparison to your parent us acid, in this, are you able to see one oxygen less? Parent us acid is H3PO3. Are you able to see one oxygen less? That's why this hypo term is coming there. Right? Now, let us go further in this here. When I draw the structure of it, it comes down to this very structure here. How many H plus donor it is? How many H plus donor it is? Only one. Very good. So I'll be able to write down this as 1 H plus donor. Okay. So if at all it is releasing this 1 H plus, formula will be H2 PO2 minus. Now can you guess the name of this particular ion? I'll just redraw this diagram a little bit below, because later on I have to write something here. Tell me. Hypophosphite. Wonderful, right? So I'll be writing this as hypophosphite. If at all hypo is coming, ortho is coming, per is coming, we are going to take it. Okay. Now, the way we had another name for phosphorus acid, here also there is another name, right? And we call this as phosphenic acid. Can you guess the name of this? The same H3PO2 can also be known as phosphenic acid. Then what should be the name of this ion? Hypo, I think, the previous one people are answering. Shridhar, it is not phosphate, beta, it is ite. Us acid is there now. Hypo word, where it is hypo? Is there any hypo here that you are using? Phosphinate is correct one. I think Avinash or Sohan has answered. Ishwar has also answered. So this one will be remove ick, bring ate. So phosphinate. Done? Shall we proceed to the next one now? Next is oxyacid of chlorine and their anion. Now when it comes to chlorine, 4 oxyacid are known here. You are having here HClO3, HClO4, you are having here HClO2 and HClO, right? This HClO3 is known as chloric acid, right? Now, as compared to ic acid, one oxygen is less. I'll be calling that as, what should be the name of that acid? Can you tell me? What should be the name of this acid? No, beta, hypo word we are not using there. Hypo is for parent, if at all it is us. Sulfuric and sulfurous you compare, na? Sulfuric was ic acid is there, one oxygen less, we replace it by us. Do not use hypo. Hypo will be used if at all you are having us acid in comparison to that one oxygen less. So this one will be chlorous acid. Okay. Then what about this? Us acid, in comparison to us acid, you are having one oxygen less. So I'll be calling this as hypochlorous. Hypochlorous acid. Now, in comparison to this ic acid, there is one oxygen more. So one oxygen more, we use a term there or a prefix which is per. So I'll be writing this as perchloric acid. Perchloric acid. Able to understand all these? What is the name of them? Chloric, chlorous, hypochlorous. Chloric and perchloric. One oxygen greater than your ic acid. Okay, now the thing is, if I see its structure, it is somewhat like OH, double bond O, double bond O, double bond O, right? Here, structure is Cl, OH, double bond O, and a lone pair. Need not bother much about the structure beta here. You all will be able to draw. Okay? Then here Cl, OH, lone pair, lone pair. Mind well, I am drawing the Lewis structure. I am not drawing the exact shape of them. Now tell me, in all of them, how many replaceable hydrogens are there? In all of them, how many replaceable are there? Replaceable hydrogen. In all, it is one, right? Now the thing is, if at all I start off from here, that if at all I am saying one H plus is lost from here, the ion which I will be getting will be ClO3 minus. Can you tell me what will be the name of this ion? An ion which you have derived, what will be the name of it? Chlorate, absolutely fine. So this one will be chlorate. Now, if I remove H plus from here, it will become ClO2 minus. What will be the name of this? Chlorite. Wonderful. So this is chlorite. Now, if I remove H plus from here, the ion is Clo minus. What will be the name of this? If in the name hypo, per, ortho, anything is there, it will be retained. Very good, Ram Babu here. So this one is hypochlorite. Wonderful. I think majority of you have written it correctly. Ishwar, Madhu, Srimai, Varalakshmi, Ash Gaming. Hai? I don't know how you people keep the name. Now, if at all I remove H plus from here, you will be having ClO4 minus. Can you tell me the name of this ion here? Can you tell me the name of this ion here? That is perchlorate ion. Wonderful. So it is perchlorate ion. Done. So at least these many oxyacid and their anions, you remember, be careful there, right? Because once we are aware of from where the anions are coming, then it will be much more easier for us to absorb anything or else write the formula of a compound properly, right? I am not telling you more than this. This is enough. Now we'll go for, kind of how to write down the formula there. Okay. And I think I've already taught you about mercurous and mercuric in the last class, if I'm not forgetting anything. Hopefully I've given you, the last class, those who have attended my class. Okay, good. Now, let us go for way to write formula of the compound. So suppose I am saying that I have got a cation here, I have got a anion here, and when I say compound, I am talking about ionic compound over here, right? Okay, Sohan, Sita, right? Now, so the thing is, which one will be always written first, a cation or anion? Which one will be written always first? Cation, right? So that's why I have placed it like this, okay? And X plus and Y minus are the charges present on them. Like if at all I take aluminium, it will be Al3 plus. If at all I take oxide, it will be O2 minus, okay? Now, next, what you're supposed to do, whatever are the charges, you are going to do crisscross of that. So you will be getting AYBX. Please do not bring their sign here, right? You are not going to bring Y minus. You are just going to bring Y. Getting it? You're not going to bring plus from there. It is only going to be X, right? So this is what is the formula of the compound, and this is actually crisscross method, right? So first you will be writing the cation, you will be writing the anion, and then doing the crisscross of them, and hence you will be getting the formula of it, right? For example, and if there is anything common which you can take out, you can take out, right? Suppose I am saying that you have to name. I am giving you the name, you have to write down the formula. Suppose I am saying that you have to go for aluminium oxide. So you know that aluminium is Al3 plus, oxide is O2 minus over here. So in that case, what we are going to do? We are going to do crisscross, you will be getting Al2O3. Right? It could also be the case, suppose they are writing here chromium 3, let us say, and they are writing oxide. Chalo. Okay. What is the meaning? Sometimes you can even get something like this. Element will be written, beside that there will be oxidation state mentioned here. So what I can go for? Chromium, this is 3 plus, oxide O2 minus, you are going to have Cr2O3. Able to get it? Now suppose if at all I have to write down sodium bicarbonate. So I know that sodium is Na plus, bicarbonate is HCO3 minus. Doing the crisscross, you will be getting NaHCO3. That's the formula of the compound. Able to get it? Now I am giving you, kind of little bit amount of time. Can you go through it, or else I'll give you question, you try it out. Hopefully everybody has, I think, last class, so you already remember, right? Today's class, hopefully it is there in your mind, whatever has the anion there. Hopefully. Questions we'll do, right? Okay. Write the chemical formula of the given compounds. The thing is, it's better you copy down the whatever is the name I'm giving you. Do not, kind of write down the answers there, because I want everyone to try it out. Okay? Because once the answer is out, nobody is, kind of in a mood to write down anything. I'm writing few names here. Siddharth, I think at your place, all the NEET students are, quite worried, and even we want, this should not happen. But, ultimately nothing could be said. It all has to come from the Supreme Court, and let's hope for the best. Okay? Do not stress, I would say, much. I'll do one thing. I'll bring all of them under one this. Are you able to read? If at all, I'm making the font very small. Up to 4, I think everybody would have written, right? Yes, Sohan has completed, but I'm waiting for a few more people to complete it, Bita. I'm including few more here. Few more I am adding to the list. So those who have finished, they can go ahead with it. Okay, these many should be sufficient for your practice. I've included few new here. So we'll bring some of them on the same page so that you can read. And once you are done, we'll discuss it off. And hopefully you people are writing on your own, not you have kept your, you are not keeping on your kind of flipping the pages there. Done, Mita. Madhu has written done. What about others? So we'll try to discuss one by one here. As such, I've included many here. If at all you remember, then it will be much more easier. Now, barium carbonate. Barium is always 2 plus, carbonate CO3 2 minus. So when you do the crisscross, you'll be writing Ba2CO3 twice. Take out the common here, you will be getting this as BaCO3. Right? Sohan, 17th one doing. Should I give you 2 to 3 minutes more? If at all somebody is already at 17th. Sohan was at 17th. 2 to 3 minutes more, I think that should be sufficient. What about others? Madhu has done, and I think Sashiram also. Okay, fine. So giving you that time, not an issue. Please go ahead. I'll discuss after 2 to 3 minutes. That's absolutely fine. Fine, Sohan. Do not waste their time there in typing the same answer again. Utilize that time to solve the question. What about rest of the people? Have they completed? Sohan, is it done, beta? I think few people, Shravanti also done, Sri Ram, and who else is there? Okay, let us discuss. I think majority of you, since you have written done and I have given you time also, let us go ahead here because it will take some time for discussion also. Now, next one here is magnesium nitride. Okay, so magnesium you should write down this as Mg2 plus, nitride is N3 minus. When you do the crisscross, you are going to get Mg3N2, right? Hopefully everybody has written the same formula, right? Magnesium nitride. Now, sodium peroxide, you are having Na plus over here. Peroxide means O2 2 minus. When you do the crisscross, you are going to write down Na2O2. Okay? Do not write down NaO here because it does not exist like that. It is Na2O2 because from the formula also you should be able to make out that this is okay. This O2 is there, one here. So Na plus and this will be O2 2 minus. Getting it? Few species will be taking out common from there also and writing wonderfully as NaO. Now, another one is ammonium sulfate. Ammonium is NH4 plus. Sulfate is SO4 2 minus. Doing the crisscross of the charges, you will be getting ammonium twice and this NH4 twice SO4. I hope that's what you have written. First one, Sharath. First one, why it is difficult, beta? First one is so simple. Barium we have written, carbonate we have written. 2, 2 both are there. We can take out the common from there and it will be barium carbonate. Now, next is aluminium phosphate. Now here it is Al3 plus, phosphate is PO4 3 minus. So you will be getting Al3 PO4 thrice. You will be writing from here AlPO4. That's what is the formula here. Not Al3PO4, Rambabu, some mistake you have done, beta. Correct. Who has written it correctly? I think Ash Gaming. Okay. Now, calcium cyanamide. Calcium is Ca2 plus. Cyanamide is Cn2 2 minus. You will be writing Ca2 Cn twice. So you will be writing Ca Cn2. 2 taken common from here. Okay, good. Now, ammonium bisulfate. You are having here NH4 plus. Bisulfate is HSO4 minus. Doing the crisscross, 1 charge is only there. So this is what is the formula. NH4 HSO4. Written? Now, next is barium azide. Barium is Ba2 plus, azide is N3 minus. Do the crisscross. Crisscross I am writing here. This is Ba. You are having here N3 twice. That's what is barium azide. Okay. Twice will come, beta. Twice you should not leave. Sohan. Now, the next thing is dihydrogen phosphate, right? So there is one thing you remember when it comes to phosphate series, which you are having as H3PO4, all the 3 H plus are replaceable. So dihydrogen phosphate, when I say, so those many hydrogens are replaceable there. Only problem comes in case of phosphite one, right? So here this is Mg2 plus and you are having dihydrogen phosphate means H2PO4 minus. When you do the crisscross, formula will be Mg H2PO4 twice. That's what is the formula. Able to get it? So you can remember that when it comes to phosphoric acid, when we are deriving the things from there is no problem in case of whatever is the number of hydrogen which are replaceable, that only we are reflecting there. Only in case of H3PO3, there is discrepancy. Okay. Then calcium phosphite. If you remember, we are having H3PO3, phosphorus acid, 1 H plus gone, H2PO3 minus. This was hydrogen phosphide. 1 more H plus gone. HPO3 2 minus, that is phosphite. Okay, so the thing is, I'll be writing this as HPO3 2 minus. When I do the crisscross, I'm getting Ca2 HPO3 twice, and ultimately I can write down this as CaHPO3. No, Rambabu, check your answer, beta. Now, for the 11th one, you are having here barium, which is Ba2 plus. Hydrogen phosphide means which one I am talking about here? Hydrogen phosphide, this I am talking about. So that is H2PO3 minus. So doing the crisscross, I will be getting Ba H2PO3 twice. That will be the formula. Barium hydrogen phosphide. Got it? Now, next is rubidium superoxide. Rubidium is Rb plus, superoxide is O2 minus. Do the crisscross, you will be getting RbO2. That's the formula of it. Ash Gaming, that's wrong with the calcium phosphide which you have written. Now, magnesium perchlorate. Magnesium is Mg2 plus, perchlorate is ClO4 minus. Do the crisscross, you will be getting the formula as MgClO4 twice. That should be your formula. Magnesium perchlorate. Now, next, potassium hypoiodide. Now, the way I have written for oxyacid of chlorine, same way you are having for bromine as well as for iodine, right? And you should remember that HClO3 was chloric acid, then HClO2 which was chlorous acid, and this one is hypochlorous acid. So similar to that, you will be having hypoiodous acid, and the thing is, when I remove H plus from there, it will be hypoiodide, the way you are having hypochlorite. Are you able to understand what I am saying? Similar to whatever oxyacid we have written for chlorine, same way it exists for bromine, same way it exists for iodine, not for fluorine. Okay. So the thing is, you are going to write down this as K plus, and you are having here IO minus. So it will be KIO. Getting it? Rambabu has written correctly. Wonderful. Now ammonium sulfide. Ammonium is NH4 plus. Sulfide is S2 minus. Do the crisscross. You will be getting NH4 twice S. That's what is the formula over here. Hopefully all of you are matching whatever we are writing now. Mercuric Hg2 plus. Chloride Cl minus. Do the crisscross. Your formula will be HgCl2. Very good. Now, when it comes to mercurous, I am writing the formula here, that is Hg2 2 plus. Mercurous means they can also write down something like this here. Mercury 1. Iodide means it is I minus. Do the crisscross. You will be getting Hg2I2. That's the formula. Then, for the 18th one, I have written stannic. Sn4 plus, bromide is Br minus. Do the crisscross, you will be having SnBr4. These are all the simple ones. Now, magnesium Mg2 plus, hydroxide OH minus. Do the crisscross, you will be getting MgOH twice. That's what is the formula here. Very good. Okay. Cesium chloride. Cesium is Cs plus. Chloride is coming from chlorous acid, which is HClO2. So the thing is, it will become ClO2 minus. Able to remember? Just now I have mentioned now, chloric acid. This one is chlorous acid. From chlorous acid, when you remove it, becomes ClO2 minus, right? So when you do the crisscross, it will be CsClO2. Okay, then Last two here, ferric. Ferric means Fe3 plus, sulfate is SO4 2 minus. I'll be able to write down this as Fe2 SO4 thrice. Fe2 SO4 thrice. Right? Now the thing is, you must remember, last one I've given you so that I can tell you one thing. This hydra acid, if at all I remove both the H plus, it becomes S2 minus, which is nothing but sulfide. And I think I might have given you also, if at all you remove one H plus, it becomes hydrogen sulfide. Or else we will be able to write down this as bisulfide. So the thing is, here it is ammonium bisulfide is HS minus, and you will be writing this as NH4HS. Got this, everyone? Hopefully it is clear to everyone whatever we have discussed. Right? With this, your basic inorganic nomenclature gets over. Right? And this is part of your Sunday's test, which you will be writing. And if at all, see, someone who got stuck up, in few questions when you were, kind of writing this, my advice to you will be, please, kind of by writing, you remember the ions, right? Normally, we have the tendency to open the book and, just, kind of read it like a novel. So things remain in air. Please make sure that you are writing. More the number of times you write, more it will get registered in your brain, right? Please write it, like memorize it by writing it, okay? And after that, you are having the questions as well as the answers with you. So just write down all the question, right? You can change the ions and anions yourself to have more practice. And the thing is, then you write down the answer and you can check against whatever we have done. That will give you a better practice, right? I hope it is clear to you. And again, I'm saying, please do not stress about the structures. Structures anyhow we'll learn later also, okay? I hope you have understood all those things. Please revise the things. Even though these are very basic fundamental, but they are required, right? So that's all for today. We'll wind up the session here, right? Chalo, see you tomorrow then, or the day after tomorrow. Thank you and have a nice day.